Hi, I am Vijayalakshmi Iyer.
I am Vanshita Boppanna.
And I am Hana, Hayat.
As 6th standard children, we are trying to understand what gears are, and hence our project, Decoding Gears.
A gear is just a wheel with teeth on it. In order for a machine to work, we need at least two gears connecting to each other.
As you can see, the bigger gear is rotating the smaller gear which is connected to a shaft, which is rotating the wheels of the toy car.
When two or more gears are connected together, they are called as a gear train. The gear which you are moving is called as the driver gear, and the gear which you are trying to move is called as the driven gear. Sometimes there are many gears between the driver and the driven gear. They are known as idlers.
The number of rotations of the driver gear to the number of rotations of the driven gear is called as the gear ratio. For example, if the driver gear is 24 and the driven gear is 48, the gear ratio will be 2:1. That means when the driver gear will move 2 times, the driven gear will rotate 1 time.
A compound gear is the number of gears fixed together. Consequently, they rotate at the same speed. Compound gears usually differ in size and have different number of teeth. We will explain this concept further in our project.
How does a clock work? As we all know that the hour hand rotates twice a day. And when the hour hand rotates 1 time, the minute hand rotates 12 times. And when the minute hand rotates 1 time, the second hand rotates 60 times.
This gear represents the movement of the hour hand. It has 120 teeth. It is connected to another gear which has 10 teeth. 120 divided by 10 is equal to 12. So the gear ratio is 1:12, which means that when this gear rotates 1 time, this gear will rotate 12 times. As it is a compound gear, its base has 120 teeth and will also move 12 times.
This gear has 120 teeth and this gear has 20 teeth. 120 divided by 20 is 6. When the minute gear completes 1 rotation, the intermediate gear completes 6 rotations. As this is a compound gear, it is fixed to another gear which has 80 teeth. The second gear has 8 teeth and 80 divided by 8 is 10 and 10 into 6 is 60, which is the number of rotations the second hand takes.
Now let us see how an hour hand rotates 1 time when the minute hand rotates 12 times.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. When the minute gear completes 1 rotation, the intermediate compound gear completes 6.
1, 2, 3, 4, 5, 6. Similarly, the second gear completes 10.
4, 5, 6, 7, 8, 9, 10.
In olden days, when there were no digital or analog computers, there used to be mechanical machines for each and every work. So, this is an instantaneous addition and subtraction machine.
First, we'll take an addition example. Let us take 3 plus 2. In rack A, we have taken 3 and in rack B, we have taken 2. You can see the answer in the middle, it is 5. Now, let us take an subtraction example. Let us take 4 minus 3, which is equal to 4 plus minus 3. As you can see in the middle, it is 1.
This machine is made up of 2 racks and a pinion. This is rack A and this is rack B, and the pinion is the C. Let us take the pinion as the output of this machine and the racks as the input. Now let us put a common scale on all 3 of them. Let us take an example. We will move rack A towards 4 and rack B towards 2. 4 plus 2 is 6 and the pinion shows 3, which is the half of 6.
Now let us see some negative examples. Let us move the rack A to minus 4 and the rack B to 2. The answer should be minus 2, whereas the answer shown is minus 1. Minus 1 is exactly half of minus 2. Hence it is proved that the pinion shows exactly half of the real answer.
As we have proved that the pinion shows half of the real answer, we have doubled up the scale so that it shows the correct answer instead of half.
These machines are a little complicated, but yet they are called as simple machines.
I hope that you enjoyed our presentation.
Thank you.